Hi everyone. I want to take you through the Unit 3 practice assignment, and I'm gonna walk you through it rather than just posting the answers. I'll walk you through kind of how I solved each question. So it's a nice little review for the final assignment in trigonometry. Okay, so here we go. Hopefully you've done this, and you can either fast forward to the section of it that you might have had trouble with, or just listen as we take it up. So it says in the following triangle, what is cos B equivalent to? So we're focusing in on this angle right here, the B angle. And we know that for cos, it's the ka portion of SOHCAHTOA. And so watch, we could say that cos is of B is equal to adjacent over hypotenuse. So adjacent is little a, and hypotenuse is little c. So there we go. Okay, number 2. It says, what number is equivalent to tan 75? Well, if you take your calculator and type in tan 75 and then hit equals, you get 3.732. Make sure you're in the degree mode. Some calculators you have to hit 75 and then tan. Some calculators you do tan and then 75. So just be aware of that. Okay. Number 3, it says, what is the length of x in the following triangle? So what I was hoping that you would notice there is that we don't need SOHCAHTOA. We can go back to our grade 9 view of things, which is that you have 2 of the sides of a right angle triangle. So we know that according to Pythagorean theorem that a squared plus b squared is equal to c squared, and where the 2 shorter sides have to be a and b. So in this case, when I look at this, I can see that x is actually the hypotenuse, so I got to put it on its own, and then it would be 8 squared plus 6 squared. And then to get rid of the squared, you do the square root, but whatever you do to one side, you got to do to the other. So x is going to be equal to 8 squared plus 6 squared, and then take the square root of that, and you get 10. Okay. Find the measure of the angle theta to the nearest degree. That's often the symbol used for angles. And so here, you have to type into your calculator, well, theta is the inverse tan of 1.23, and so when you type that into your calculator, it gives you 51 degrees. Okay, here's another practice one of those. So here you'd have to go type into your calculator the inverse cos of 0.897, and when you type that in, you get 26 degrees. All right, so here we go. Another right angle triangle. It says solve for x. Well, again, the problem with this one is we don't know the other side, so we can't use Pythagorean theorem. So we have to use one of our trig ratios. And so what we're going to do here is relative to the 40, we know that this side B here is the adjacent, and we know relative to the 40 that side C is the hypotenuse. So we're dealing with A and H, so we need cos. So we would say cos of 40 degrees is equal to adjacent over hypotenuse, and so it's 6 over x, okay? And now we've got to get x by itself. And so again, what you can do here is if you multiply this side by x and this side by x, you've done the same thing to both sides, and you have an x over an x, so that cancels, so you can get rid of that. And that's, I was showing you that in yesterday's lesson, that you can actually cross multiply the x over. And then we need to divide by the cos 40 because we want x by itself, but we'd have to divide by the cos 40 on this side. Okay, so finally end up with x is equal to 6 over cos 40. Type that into your calculator, and you get 7.8. Okay, next page. It says in triangle XYZ, angle Y is 90, XY is 7, YZ is 24, and XZ is 25. What is the angle X? Okay, well, I started this one by saying to myself, well, I know that we've got to have a 90, obviously. We got a 90-degree angle at y. And then I saw that xy is just this little short one, and yz is this big long one. And so what I did was I came over here and I drew this little short one right here, and I labeled this y, and I started going up because I knew there was a right angle there. So I kind of knew that y was a right angle, so that took care of that. And then I made this point right here, I made it x because I knew it was really short. So xy is only 7 units long. But yz was 24, so it's way up here. So I'm going to keep going up and up and up. Okay, and look, it's 24 units, and that's probably not even to scale, but anyway, it's close enough. And so I'll make that z, and then I got to join, oops, that wasn't a very good one. Let me try to fix that. So then I'm going to try to join here. I'm actually going to use my line tool. I'll join, there we go. Okay, and so that's xz, and so that was 25. And it looks good. It looks good, like, you know, it's going to be a very long and narrow triangle, and so I just used my knowledge to kind of draw that out the best I could. Okay, so I've got 3 sides of this triangle, but they want me to solve for this angle here, this angle right there. So I decided, well, really, because I've got all 3 sides, I can pick any of my trig ratios. I could use SO, CA, or TOA. So I just said, well, I'll pick sine. So sine of x, and there it is right there. It's opposite over hypotenuse. So the opposite of x is 24. That side right there is opposite the angle. And the hypotenuse is 25. And so basically, x is going to be the inverse sine, that's my inverse button on my calculator, of 24 divided by 25. So when I type that in, I get 74 degrees. And that makes sense. That'd be a steep angle there. Okay, number 8. Number 8, we now get into, this is kind of warm-up problems, and this is one where it's no longer a right-angled triangle. Now, interestingly, it says, well, what's x? You got to solve for x. And I know that I've been given 2 angles. I could get the third angle if I wanted. You know, sometimes it's nice just to do that. So I'd go 180 minus 79 minus 51, and I'd say, okay, well, that angle's 50. Okay, so I know that. But I notice that I have an angle, this 79, and I know it's opposite side. And as soon as you see that, you know that you can use sine law. Okay, well, I'm going to label my triangle. So I'm going to call this capital A, this one up here capital D, and this one down here capital C. So that makes this one little a, the x is little a, the 18.4 is little b, and we don't know little c. And then I'm going to write sine law. So a over sine A is equal to b over sine B is equal to c over sine C. Okay, so now I'm going to substitute in what I know. So look, my little a is actually the x that I'm looking for. So x over sine of 51 is equal to b is 18.4 over sine of 79. And c I don't know, but I do know what sine c is, sine of 50. Okay, so here, remember with sine law, we focus in on 2 of the ratios. So clearly, I'm going to use these 2 because this one has the x in it that I'm looking for, and the other one has both of them. So you gotta do that. So now I just have to get x by itself. So I'm going to come over here and say, well, x is equal to. Well, look at this. To get rid of the sine 51, I've got to multiply both sides by sine 51. So really, look at what I'm doing. I'm cross multiplying it up here. I'm not going to cross multiply the sine 79 up because it's already on the side without x. So I end up with 18.4 times sine of 51 degrees divided by sine of 79. So that's how you get x by itself. And when you type that into your calculator, type it all in, you end up with 14.6 meters. Okay. This question here, number 9, should have been out of 6 marks because it's actually, the hint here is that you need to do 2 steps. So a lot of you might have had some difficulty with this one, but let's take it up. So look at this. They're asking you to solve for this angle right here, R. Well, we know little p is equal to 5.4. We know q is the 39, and we know little r is equal to 3.9. So notice that we've got 2 sides in a contained angle. So definitely this is a cosine law. Unfortunately, we have no opposites here, so we have to use the cosine law. All right, so that's kind of something right off the bat. Well, in order to use cosine law, the first thing I'm going to have to do is I'm going to have to, I need to solve for, I've got to solve for this side. I've got to solve for little q. And the reason is I don't have enough information to solve for the other 2 angles. The only thing that cosine law right now is going to give me is that q. So here we go. I'm going to go up here to do it. I'm going to say, well, q squared is equal to p squared plus r squared, so it's the other 2 sides, minus 2 times p times r cos of capital Q. That's how it goes if we're trying to solve for q. So let's substitute in what we know, which is 5.4 squared plus 3.9 squared minus 2 times 5.4 times 3.9 cos of 39 degrees. Okay, so that's q squared. So now what I'll do is I'm going to gradually do this, and so I do 5.4 squared plus 3.9 squared. I'm going to do it gradually. I get 44.37 there. And then I'm going to do 2 times 5.4 times 3.9 times cos of 39, and I get 32.73 there. And now finally, I've got to do the square root because I have to get rid of the squared off of both sides. And when I do that, I do this minus this square root, I get a length of 3.4. Okay, so we know that little q is 3.4. Now the thing is that now that I know little q, I now have a set of opposites, and so I can use sine law. So watch this, and watch how I'm going to do this. I'm going to write sine law. I'm going to write it like this. It doesn't matter which one we write on the top, so I'm going to go sine r over little r is equal to sine q over little q is equal to sine p over little p. So again, it doesn't matter whether we write the lengths on the top or the angles on the top, as long as we're consistent. So now I'm going to sub in. So I don't know what r is. I'll just write sine r over little r. Well, little r is 3.9. Sine q, I know, is sine of 39 degrees divided by, and look, I know little q now. It's 3.4. Sine p, I don't know. I'm going to put just p there, and then over little p is 5.4. So clearly, with sine law, we're always focused on 2 of the ratios, and so I'm going to work with those 2. And so I'm going to come over here, and I'm going to write sine of r is equal to, and I'm going to cross multiply the 3.9 up, so 3.9, I'm multiplying it up to here, sine of 39 divided by 3.4. And when I type all that in, I get 0.722. So r is going to be the inverse sine of 0.722. And when you type that in, you get 46 degrees. Okay, so that was a tough question. All right, well, let's try some application. Okay, so the first application question is an interesting one. It's kind of asking you to find an error in a question. This is an interesting type of question often used in math. And so it says, Sylvia was looking for the side of a triangle. Is Sylvia's solution correct? If she is correct, explain the steps involved in solving the problem. If she is incorrect, describe her error. Okay, so you can see that definitely Sylvia was using the cosine law here because she had two sides in a contained angle, so that was part of it was correct. And it looks like she has called this is capital C, and because that's, I can see that she substituted 53 in there, and it looks like she has called this capital A and this little a, and this capital B and this little b. I can just see by how she substituted it in there. So it's all looking pretty good so far. So she plugged in the 8 squared and the 13, and she did -2 times 8 times 13, cos of 53. That's looking good. And then she said, well, 8 squared plus 13 squared is 233. Perfect. Minus 208 times cos of 53. That's looking good. Oh, I see her error. Look what she did. As she did this, did 233 minus 208 and got 25. That's not correct because according to BEDMAS, you had to multiply these two first. So I'm going to put a little star here, a little star, and say you must multiply 208 times cos of 53 first. You can't subtract those. That's not following BEDMAS. And so if I had done that, so I'm going to cross this out and cross this out. They're wrong. If I had done that, I would have got, if I had done 233, it would have been minus, and then 208 times cos of 53, I would have got 125 there, and then 233 minus 125 equals 108. But remember, that's c squared still. And so the last step would have been to take the square root of both sides. And so c should have been, it should have been 10.4. 10.4 centimeters. So I've made the correction. I've tried to indicate where they made their mistake. That's perfect. Okay. Here we go. Number 11. So it says from the top of the CN tower, the angle of depression to the tip of the tower's shadow is 88 degrees. So remember, this is the angle of depression here. The shadow is 19.5 meters long. How tall is the CN tower? Okay. So we're going to have to draw a picture of it here. So I'm going to draw the CN tower. Here, I'll draw the ground. And then I'll draw the CN tower right here. I don't know, kind of looks like this. It's this big tall tower. Okay, so there's the CN tower. And relative to the CN tower, it's got a pretty short little shadow. So I know it's not going to be completely to scale, but let's just say that there's a little shadow down here. There's a little shadow right there, and it's only, that's only 19.5 meters long. I'm going to now just use my line tool to fix this up. So if I went straight up to the top of the tower, and then I'm going to draw, oops, I'm going to draw another one. I'm going to draw another line from the top down to there. Okay, so here we go. So I'm just going to draw a line going straight across here. So remember, the angle of depression is, as you look, it's this one right here. So that is 88 degrees. Now that's not in the triangle. So the one that's in the triangle is this one right here. So that's 2 degrees because I know the whole thing must be 90. And so 88 plus 2 would be 90. So I got a 2-degree angle there. But what they want is x. They want the height of the CN tower. And look, this is a right-angled triangle. Oh, okay. So watch this. I can just use SOHCAHTOA. So relative to the 2 degrees, and I'm going to change colors here, relative to the 2 degrees, the 19.5 is opposite and the x is adjacent. So here we go. I can just say that tan of 88 degrees is opposite over adjacent. It's TOA, remember, TOA. So I would say it's 19.5 over x. And to get x by itself, I'd bring x up here. So I'd multiply both sides by x. That gets rid of it. And then divide both sides by tan of 88. That gets x on its own and at the top. So x is equal to 19.5 divided by tan of 88. And when you do that, you get 558 meters. Okay, couple more questions. Number 12. It says determine the area of a triangle that has sides measuring 6, 8, and a base of 12. It is not a right-angled triangle. Okay, that's important. And they want it to be accurate to the nearest tenth of a centimeter. Okay, so we got to use this formula to get the area. But let's start by drawing this. And so it's got this long side here of the base, and that's 12 centimeters. And then it's got these two shorter sides. So it's got an 8-centimeter side, and it's got a 6-centimeter side. So there's the 8-centimeter, and there's the 6-centimeter. It's just a ballpark. So if I know that the 12 is the base, in order to calculate, so I've already got a lot of the area formula, I just need the height. Well, the height, we know, comes straight down here. So that I need that height measurement. Okay, and it does come down at a right angle. Okay. Well, I'm going to label my triangle now. I'll just label it A, B, and C. So that makes this one down here little b, this one little a, and this one little c. So what I notice is that if I'm able to get an angle, if I was either able to get angle A or angle C, if I was able to get either of those angles, then all of a sudden I would have a right-angled triangle, and it doesn't matter whether it was this this first one here on the left or the one on the right. And as long as I had that, I would have an angle and a side. I could use SOHCAHTOA to get the other side. So my goal here is to get A or C. Now, in this big triangle, so I'm looking at the big whole triangle ABC, and I notice that if you're given 3 sides, I've got to use cosine law. So I'm going to work on getting A. And look at this. This is up here is a form of cosine law. So I'm going to write cos of angle A is equal to B squared plus C squared minus A squared over 2BC. Okay. Let's plug our numbers in. So here we go. I am going to write 12 squared plus, 8 squared minus 6 squared all over 2 times 12 times 6. Here we go. So when I do all that, I get a number of 0.806. and that's cos of A, and then finally A is going to be equal to the inverse cos of 0.806, and I get a number of 36.3 degrees. Okay, one really quick thing I want to address. A couple students have emailed me about this, and I want to just show you one thing about cosine law, and I'm going to go to another page to do this. Actually, I'm gonna copy and paste these two over just for a second, just to show you something that was causing a little bit of confusion for students, and I want to just clean it up. So I'm just going to copy this to another page, and a lot of students are saying, Mr. Webster, sometimes when you isolated the angle, you got a negative. And so look at this. I just want to show you this, that a lot of you said, well, Mr. Webster, if you just go directly from here and isolate cos A, you end up getting this formula. You end up getting A squared minus B squared minus C squared. So you move the B squared over and the C squared over. And then you've got to divide by negative 2BC is equal to cos A. So a lot of you said, I've done that in another video, and people are saying, well, that doesn't look the same as this. But just remember that I want to show you something here, is that as long as I do the same thing to the top and the bottom of a fraction, it doesn't change. So watch this. If I multiplied the top and the bottom by -1, I'll just do this right here. As long as you do the same thing to the top and bottom of a fraction, you don't change it. So A squared minus B squared minus C squared and negative 2BC. Okay, so I'm just showing you this. And watch what happens now. If you do -1 times negative 2BC, on the bottom you end up with 2BC. It just gets rid of the negative. And then look on top, you'd end up with negative A squared plus B squared plus C squared equals cos A. And watch this, if I was to rearrange that, I could say that cos A is equal to, it's equal to B squared plus C squared minus A squared, doesn't matter the order that you do those in, divided by 2BC. And so I'm just showing you that they're both the same. It doesn't matter. You know, you could use just a rearrangement of this one like I've done in previous videos, or you could use this maybe easier one with less negatives in it. Okay, so back to this question then. We solved for angle A, and now I'm just going to change colors and look at this. I'm going to focus in on this triangle, and I'm actually even going to write it down here. I'll show you. You've got a little triangle here. You've got this side is 8. I don't know what, 12. I don't know whether this is what portion of the 12 it is, but it doesn't matter because I know that this is 36.3 degrees, and I'm looking for the height. So here I go. I'm going to say that sine of 36.3 is opposite over hypotenuse, so it's the little h over 6, because I've labeled that the height of the triangle. And so h is going to be 6 times sine of 36.3. And so when I do that in my calculator, I get 3.6 meters. So we're almost there. The area is the base times the height divided by 2. So it's 12 centimeters is the base all the way from there to there. The height is 3.6, and then I got to divide by 2, and I get 21.6 centimeters, squared. Okay. Centimeters squared. Having some difficulties here. Centimeters squared. There we go. Okay. Last question, number 13. It says an isosceles triangle has two sides that are 5.5 centimeters long and two angles that are 32.4 degrees. Determine the perimeter of the triangle and the area. Okay, well, I'm going to start this one by drawing it. And actually, I think I've got a tool here for doing it. That one right there. So I'm going to draw it like this. Okay. And actually, I think what I'm actually going to do, it turns out to look like this actually, but I'm going to make it a little bit bigger. All right, just give me a second here just so that I can fit everything. So it turns out to look like this, interestingly enough. So this is also isosceles because look at this. I'm going to say that this is side A, or sorry, angle A. This is B, and this is C. And so if this angle here is 32.4, this angle is 32.4, and then we're told that this is 5.5 centimeters, and this is 5.5 centimeters. Okay, so this is what we're given. We can certainly get angle A by knowing that the sum of the angles in a triangle is 180. So we can go 180 minus 32.4 minus 32.4, and you get 115. So this right here is 115.2. Okay, and now look at this. Let's get side little a. So I'm going to call this little c, and I'm going to call this little b. And so let's get side a, because then we'll be able to get the perimeter. We'll have all three sides. And so here we go. I'm going to come over here, and because I've got some opposites, I can use sine law. So I'm going to go a over sine a is equal to b over sine b is equal to c over sine c. Okay, and then what I'm going to sub in my numbers here, so little a over sine of 115.2 is equal to 5.5 over sine of 32.4. It's equal to 5.5 over sine of 32.4. So obviously we don't need both of those. We can just work with, let's work with this one right here. And so I can get a by itself by going a is equal to 5.5 times sine of 115.2 divided by sine of 32.4. And when I type that into my calculator, I get 9.3 centimeters. And so now I can get the perimeter, which is 5.5 plus 5.5 plus 9.3. And when you do that, you get 5.5 plus 5.5 plus 9.3, and you get 20.3 centimeters. Okay. And then for B, I've got to do the area. Well, again, this is very similar to the last question, is that I don't know the height of the triangle. I know that the base is, I know A now is 9.3, but I don't know the height of the triangle. And so as soon as I get the height, I can go area is base times height divided by 2. So I've got the base, I need the height. And so I look at this and go, well, I can just use SOHCAHTOA because I know this angle. And so I can say that sine of 32.4 is equal to, and I'll call this h, it's opposite over the hypotenuse, which is 5.5. And so the height of the triangle is going to be 5.5 sine of 32.4. And when you do that, you get 2.9. And so then the area is equal to 9.3 times 2.9 divided by 2, and you get 13.5 centimeters squared. So there's the practice test. The real assignment will be tomorrow. I'll post that assignment, and then people have a few days to finish that and submit it to me. Good luck, everyone.